In section 4.4, we're going to talk about how do we name certain kinds of polygons and how do we calculate the interior angle sums for those polygons. And we've already been talking about one polygon. We've been talking about a triangle for a couple of days. And a triangle is actually a polygon. The formal definition for polygon is a shape consisting of straight, non-intersecting line segments. So again, a triangle is a three-sided polygon. So what they mean by straight, of course, straight lines, but so if you think about a circle, that is not made of straight lines, so that would not be considered a polygon. And what they mean by non-intersecting, if you think about like a star shape, that would be considered not a polygon because it has intersecting lines. So things like a triangle, right? We know what a triangle looks like. A triangle would be considered a polygon because it's made up of three non-intersecting sides. The rest of these in this table are things that I'll ask you to memorize. So if it's four-sided, what kind of polygon is it? It's actually called a quadrilateral. Now you might think, oh, it's a square or it's a rectangle. Those are special cases of quadrilaterals, but just a regular old four-sided polygon is considered a quadrilateral. We don't know necessarily what type of quadrilateral it is till we see its picture. All right. If it has five sides, the polygon is called a pentagon. If it has six sides, the polygon is called a hexagon. If it has seven sides, there's two different names, but the one that is in our book is called a heptagon, but some of you might know it as a septagon. I think in chemistry class they teach it as a septagon. Septagon is Latin and heptagon I think is Greek, so we're using the Greek word for seven-sided polygon, so I'm going to use heptagon. An eight-sided figure is called an octagon. A nine-sided polygon is called a nonagon. That's usually one that students struggle with. Nonagon is for 9 sides. A 10-sided figure is called a decagon. And then I don't know why we skip 11. There's nothing for 11, but a 12-sided figure is called a dodecagon. So anytime I'm referring to a polygon by its name, you should know how many sides it has, okay? So those are things you should have memorized. And a lot of them I'm hoping you already know. Most people know 3, 4, 5, and 6, and 8 and 10. And so usually it only requires a little bit more memory work. Now, if we had something like a 13-sided figure or a 14-sided figure, you call it like an n-gon. And so an n-gon just means if I had a 13-sided figure, I would call it like a 13-gon. And if I called it a 13-gon, so this is just an example, you know it's just a 13-sided figure. Now, there probably are special names for 13 and 14 and 15-sided figures, but for our purposes, we're going to call it either like a 13-gon, a 14-gon, or a 15-gon. So that's anything above a 12 is just going to have the number and then dash gon. All right, so like I said, I'll expect you to have those memorized. And when I give you a picture of a polygon, which again, look how it's made up of straight, non-intersecting sides, I would expect you to be able to name it. So of course you have to count up the sides. So I'm going to number them 1, 2, 3, 4, 5, 6. So that's a 6-sided figure, so you should know that is a hexagon. The next one, you might think it's a square, but we don't really know if it's a square. A square has to have 4 right angles. It sure looks like they're right angles, but since I don't see the box in any corner there, and I also don't know that it is all the sides are the same, so therefore we just want to call it a quadrilateral. So don't give it like a particular name of a 4-sided figure. Give it the generic name for any 4-sided figure when you don't know exactly what it is. So that's a quadrilateral. All right, so you'll have some of those to name on your homework tonight. You'll have some polygons to name. All right, another thing that we want to learn how to do in this section is we want to learn how to calculate what's the interior angle sum of any polygon. And we know what a triangle is, right? We've learned that in the last, I think, 2 sections ago. We learned that in the inside of a triangle, everything adds up to 180 degrees. So the 3 interior angles will add up to 180 degrees. Well, what if it's not a triangle? So you can see I have a quadrilateral, a pentagon, and a hexagon in these pictures. And if we want to know, well, how many degrees are inside that, we could split it into triangles. because triangle's a shape we know. We know a triangle has 180 degrees. So if we take this shape and split it into 2 triangles. Now let me tell you why I picked 2, because some people want to go, oh, I can split it into 4 triangles. The reason you don't want to do that is you want all the angles of the triangle to match up to the interior angles of your polygon. So if we go and put just a single line in here like this, and if I numbered all the angles in the triangle, in this left-sided triangle, there's 3 angles. And in the right-sided triangle, there's 3 more angles. And so all of those numbers are at the interior angle of the polygon. So this quadrilateral has 4 angles, which I've split now into a 1 and 4. One of the angles is a 5. The other one's split into a 2 and a 6. And then the other one's a 3. So you want, when you draw your triangles, you want the angles of the triangle to line up with the angles of the polygon. And so I know that I just split that quadrilateral into 2 triangles, right? So 2 triangles times 180 degrees gives me 360 degrees. I know that I have 2 triangles happening inside there. Each triangle is 180 degrees, so a quadrilateral has 360 degrees in the interior. All right, let's try it again. Let's try it with a pentagon. So let's do the same thing. Let's split it into triangles, but making sure that every time we do that, all of the angles end up, the inside angles of the triangle end up at the corners of our pentagon. And so if we split it into 3 triangles like that, all of the angles, again, are going to be at the interior angle position of the polygon. And the way you can make sure that happens is pick one vertex. So I picked this vertex here, and I drew what's called the diagonals in. If you go from that vertex to any opposite vertex, you can create these 3 triangles. And so I know I have 3 triangles. Each of them is 180 degrees. And if we multiply that out, we get 540 degrees. So anytime you have a pentagon, no matter what it looks like, it'll have 540 degrees in the interior angles. All right, one more time. Let's try it one more time. So again, if you draw triangles inside this shape, it's a hexagon. So I'm going to pick one vertex and I'm going to draw in some diagonals so that all of my angles in my triangles end up being on the corners of our hexagon. And we have created 4 triangles, right? We have 1, 2, 3, 4 triangles. And so we have 4 triangles times 180 degrees equals, if we do that math, let me see here, it's 720 degrees. All right? So every hexagon will have a total of 720 degrees if you added up all its interior angles. And so rather than taking the shape and doing what I'm doing here where I'm splitting it into the triangles, see how I'm splitting it into the triangles each time? Instead of doing that, there's actually a formula we could use. We don't have to keep splitting it into triangles like that. So the formula says if we want to sum up the interior angles, so I use S with a subscript of I to represent sum of the interior angles, it's 180 degrees for every triangle you can form. And I don't know if you noticed a pattern here, but we had a 4-sided shape in the first picture and we were able to break it into 2 triangles. In the second picture, we had a 5-sided shape. It was broken into 3 triangles. In the third shape, we had a 6-sided figure that was being broken into 4 triangles. We were always able to go 2 less triangles than the number of sides. So we're going to call that n minus 2. We had 2 triangles, a 4-sided figure in the first shape minus 2. 4 minus 2 gives us that 2 that I have highlighted in yellow. In the middle shape, we have 5 sides. So 5 minus 2 gives you 3. That's that 3 that I have highlighted in the middle picture. And then for that last picture, the n stands for the number of sides. Take 6 minus 2 and you get 4, because you can break a 6-sided figure into 4 triangles. So n minus 2 represents how many triangles you could actually break the figure into. And you'll multiply that times 180 degrees. All right, so for every triangle you can make on the inside of the figure, you get 180 degrees. And notice here where it says n is the number of sides. All right, so let's do a couple examples. For example 2, first we have to know how many sides. So it's asking us to calculate the sum of the interior angles. So that's going to be the SI formula, right? So all you have to do is take the number of sides minus 2 times 180. And so let's count the number of sides. We have 1, 2, 3, 4, 5, 6, 7. This is a 7-sided figure, so I could make 5 triangles out of that 7-sided figure. So I would have 7 minus 2 times 180. And if you take that, 5 times 180 is going to give you 900. So in a 7-sided figure, you will have 900 degrees. All right, let's try it again. In the next one, we want to calculate the sum of the interior angles, so let's count up the sides. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. A 9-sided figure can be broken up into 7 triangles, so 9 minus 2, right? It's always 2 fewer triangles than you have sides. So 9 minus 2 times 180 degrees is going to be 1,260 degrees. All right, so take the number of sides minus 2 times 180 to get the sum of the interior angles for any shape other than a triangle, right? A triangle is going to be 180 degrees, and every other shape is going to be a multiple of 180. All right, one final kind of problem we could do with that is we could calculate a missing angle in a shape. So remember that when we were doing triangles, if I asked you for the missing angle, right? If I had one missing angle and I told you, hey, this one's 40 and this one's, or 50 and this one's 30, you would add it all up to 180 and solve for x. We're going to do that same thing, but we're just not going to add them up to 180. They don't add to 180, right? This is a 4-sided figure, 1, 2, 3, 4. So a 4-sided figure is not going to add to 180. It's going to be 4 minus 2 times 180. So it's going to add to 360 degrees. So I'm going to take the inside angles, the x plus the 108 plus the 121 plus the 59. I'm going to add up those 4 angles, and instead of setting it equal to 180 degrees, you're going to set it equal to 360 degrees. All right, if we add up those numbers, we get x plus 288 equals 360. And if you subtract 288 off of both sides, that missing angle is 72 degrees. So over here, you're going to get 72 degrees. And if you add up all of those numbers, you will get 360 because we know that those numbers should add to 360. All right, so that's the lesson for today. Know how to name the shapes that are in this table. Know how to calculate the number of degrees inside by doing the n minus 2 times 180. And sometimes you'll actually have to figure out a missing side. So this one would be missing angle. This one would be a 2-step process. First, figure out what the numbers should add up to, and then add them all up and solve for your x.